Hi everyone. My name is Jack. I'm a JavaScript engineer currently working at Tokyo. 皆さんこんばんは。JavaScript エンジニアといったら、多分皆さん、ウェブ開発とか、そういう、なんていうか、ちょっと簡単めな、ハードコアではないレベルのエンジニアだかな、なんとかそういう気はしますけど、やっぱり仕事をしながらどんどんサーバーサイドそういうハードコアレベルの仕事をしたいかなと思って、正直に言うと Google に行けたらいいなっていう考えでちょっとリートコードを始めようかなと思っています。だから、自分がアルゴリズムそんなに得意ではないので、ちょっと多分難しいと思うんですけど、頑張っていきたいと思います。毎日、できれば毎日せめて、1問とか2問とか、そういう解決できたらいいかな。リートコードは、だいぶ数年前に一度やってみたんですけど、その時は90問までやってみたんですけど、終わった途端、もうすぐ忘れちゃって、その後一度 Google の面接を受けたんですけど、やっぱり電話面接の時にも失敗しちゃって、その挫折を感じて、未だにも一度も挑戦してなかったんですけど、5年後、もう一度挑戦しようかなと思います。じゃあ、早速始めようと思います。当時、5年前はもう360問ぐらいですね、数は。今はもう1000超えてるんで、ちょっとハードルがどんどん上がってきてるんですけど、うん、とりあえず頑張っていきましょう。えーっと、So we are starting with the first question. This two sum. This one is very easy. It has a 43% of acceptance. The first one is two sum. Let's take a look. Okay, let's read the description. Given an array of integers, return indices of the two numbers such they add to a specific target. You may assume that each input will have exactly one solution, and you may not use the same element twice. Example, given numbers of 2, 7, 11, 15, target is 9, because number 1, the first one and second one plus sum of the first two numbers are 9, so you return 1, 0, 1. Okay. This one is, I think it's pretty forward. We have the target, and because we don't have the order, right? There's the array is not ordered, so we have to just check. Check one by one, and it will result in a big O n square. Let's first do that. So this is very simple. We just pick one number and pick one of the rest numbers one at a time. It's just a two time traversal. I'm not sure. 英語は正しいのかわかんないんですけど、とりあえず面接は多分英語なので、英語でやっていきたいと思います。Okay, so we'll write in JavaScript. I'm good at I write JavaScript most of the time, so I'll just write the algorithms in JavaScript. It doesn't matter. Actually, it doesn't matter whether you C or other languages. It's just a matter of how you upload your ideas. But the ideas doesn't change according if you change your language. So JavaScript is the best. But it seems as the JavaScript is only support is wrong with Harmony, enable the new ES6 features. Wow, this good. This is very cool. So we can use the new method. Okay, so for the first one, we will just say okay. Or for me, I would just say const length equals nums length, and let I'll just say I equals 0, j equals 1. Okay, so while I okay, it doesn't matter, so just use for loop. It's very simple to understand. For I is smaller than length. I'll change it to total minus 2, because you know and this is the loop for I, because I cannot go to the last number, and for each round of I we will put j equals I plus 1, and for this is not cool, it's okay. Equals 0, 1, j equals 1 for okay, I don't need to declare it. Say j equals I plus 1, j is smaller than total minus 1, j plus. Okay, if nums I plus nums j equals target, let's return I and j. So this is the end. Let's take a look at the last one. Oh, I think it's no problem. Let's just run the code. Bug free is very important. Bug free is とても大事なので、できればサブミットする前に一度自分のコードを見て問題あるかどうかを最終確認をします。これ見ると多分大丈夫かな。なので最後コメントだけここのtime complexity is very easy. It's n because we have n times of first I and n the same for j, so it's O n 2. Yeah, it's n square. Okay, let's submit. Wrong answer. Oh shit. Output on what is it? So the input is 3, 2, 4, and 6. And say, oh shit, I made a mistake. So here is, oh sorry, this is my bad. It should be. This is not smaller and equal, but smaller. So this one should. I run it for second time. Okay, it's accepted. It runs 1 and 22. It's faster than 21%, 51%. Let's look at the details. Wow, the other one is super fast. They are very fast. It's twice as fast as me. So is there a way we can improve it? I'll take 1 minute to think about how I can improve it. So the first thing is that Oh, yeah, I can think of the improvement for, and this is very important for as what I've seen on the internet is that when you're taking an interview with the engineers, the first round you should just give some solutions that can run, and it doesn't need to be very perfect. It has it is the brute force implementation. It's okay, and after you finish it and you look back and pick up the points where you can improve. So let's look at again. Okay, so one thing I can remember is that I can see is that, let's say if you have 1, 3, a 2, 4, and 1. This is on ordered list. Take this into consideration. If it is sorted, let's say 1, 2, 3, 4, and if this is the case, we can improve the time by faster short circulate. Whether I'm making it right, I mean stop the traversal, stop the loop at an earlier time. Let's say if we want to find the sum to 4, let's say 1, 2, okay, 1, 3, okay. If this is 4 and 5, 1, 4, it's already 5, so we don't need to check the rest. So we can stop here because it's too big, and we will check again from here. So if we can sort it, we can make it better. So about the sort, if we can sort it, what's the, if we sort it and then we average it, take a look at it, we will, I don't know if I can make it faster. Okay. Let's just take some let's do some cheating. The first one is we sort it. Actually, the sort would be what's complexity of sort? Oh shit, I don't remember. Like the first round, I will sort I think we can make it like what? I forgot. Sorry. The quick sort. It's N O N log N. Right? It's faster. But okay, let's forget that. Let's just a sort. A B return A minus B. And now we can here, right? Oh wait. Yeah. We have to sort it before we can break at early time. And the first one and sum. let's just catch the sum equals nums I plus nums j. So idea here, we just add some if. If sum equals target, we return. If sum is bigger than target, we break. And if nums I is bigger than target, we break. Because we have a solution, so we can just safely ignore all the things. Okay. Eh? What? Output 0, 2. Ah, I cannot do this. Sorry. Ah, shit. It's very hard because if we sort it, the index will be wrong. I have to give it up. Shit. I don't know, man. How can I improve? Let me see. Because return the app just even assume that each input will have exactly one solution. I may not use the same element twice. I don't think we have any. Oh yeah, I have one. The thing is that if nums I is bigger than target, we can just continue, right? And the same for this one. If okay, so if the first number is bigger than the target, we can ignore this the rest of this round. And if the second one plus oh yeah, and if we skip or not, it's doesn't make any difference for J. Because we don't know if the next number matches the condition or not, so we're just run this again. Huh? What? Okay. Sorry. It is not. So not all the numbers are the positive numbers. Okay, man. I don't know. I don't have any other solutions. Let's say if there are any discussions about this. Sorry, I gave it up. Oh yeah. I look at the, let's say someone says hash map ONO. Sorry, I know what to do now. Okay, so the thing is that we can traverse this array for one time, and to check the other one. Yeah, because it's numbers, we can just access it directly. Access the counterpart. Like we just traverse this array for one time, and remember each number's existence. Okay, so the second round, if we may, let's say we pick 2 and we can directly access to the map for 7. If it exists, we just return them. Wow, this is cool. So sorry, sorry, I'm so stupid. Okay, so the const map equals, we just use a map, and first we will just equals create the map. This is one is o n I smaller than nums nth I map I nums I equals I. So the key is the value. The value is the index. So now we create the map. So and for the second round, for let j, like we can say use the same I nums nth minus 1 I plus plus. If map target minus nums I, so we just directly access the counterpart. If it exists, so here is the problem. If it exists, we'll say if equals not undefined, we just return I and map this one. Okay, we just cache. It's okay, right? If the I number and the counterpart if exists, we just return it. Wow, this is cool, and we finished it. This is also O n, so totally O 2 n. It's totally O n. Yeah. We submit. God. First, 3 4 2 4 3. We just loop through all the arrays, and then we set the 0 sets the index, so the map should be fine. And then we let 0n plus plus, so the number is this one, so the counterpart is the same one. Then sorry, I ignored. Say you may not use the same element twice. This is the sorry, I cannot. So here it is this problem problematic problematic. So 6 is double 3, so we cannot use it again. And it should be if it is not undefined and the target. So okay, so the I just to say const let next counterpart index equals map this one. I'll say if and it should not equal I itself. Okay, so this is the full. Okay, it's accepted, and we improved. Wow, we just we now bits most of the bits. So memory use we're top 16%, and we are top 10 of the time. And yeah, it's okay. And anything we can improve is that we may any more things to improve. It's that we use the map, and we use oh, there's nothing to improve, right? To make it faster, even more faster. Oh. It's okay. Yeah, I think we are okay with this one, so let's well go to the next one. Oh, and I didn't make it. I couldn't make it at the first try, and it's very bad. 次の問題見ましょう。Number 2, add two numbers. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. Okay, so we got an example. Is a non-empty linked list 1, 2, 4, 3, 5, 6, 4. Add it 7, 0, 8. Explanation. Wow. This is very simple, I think. We just add them one by one and set a flag of a carrier. And add them. But the one thing is that the two linked lists may not be at the same length. So we should pay attention to that. But we don't know the length until we traverse them. So we just use two pointers and do that. Okay, so first take a look at our JavaScript, the load nodes definition, file. Next is the nodes. Okay, so link list 1, link list 2. So we let P1 and P2. P1 equals L1, P2 equals L2. Okay, while P1, we should stop. We should stop if one of the lists is traversed or is done. So we want P1 while P1 and P2. If both of them exist, and how can we will create a new one? Yeah, let P3 equals new list. New list node. We should just say it's start. So P3, and we return because we want to add the new result to the result linked list. So we just return p3 dot next. While p1 and p2, okay, we will say p3 next equals new. Okay, sorry. Sum equals p1 value plus p2 val. We will add a flag of carrier equals 1, 0. If sum is bigger than 9, let's sum. If sum is 4, and we set carrier 1 and the sum and minus the sum by 10. So it should be if the S1 carrier should be 0. Okay, so sorry, I forgot to add the carrier. So every time I add something, we add the two numbers from two linked lists and the carrier. If the sum is bigger, we set the carrier. We divide. Oh no, sorry. We subtract 10 from the sum, and we set the, or if nothing, we set the carrier to 0, and we create a new node, which is p3 next equals new list node. It's sum. Okay, so this is done, but when things stop, like like there is another p. Okay, sorry. We should say p1 equals p1 next, p2 equals p2 next. So now there are some cases. First one is that if some of the linked list is not done yet, and there might be a new the carrier might be non-zero. We have to we have to tackle these two cases. The first one is what's the elegant way of doing this? Okay, the first thing is that first we will make sure that all the lists are done. So if p1 is not empty, we should, if p1 is not empty, p1 is not empty, we should okay. While p1 equals p1 next. If, wow, we have to write all the logics logic again, like they are the same logic. So we should make a change. Is that P1 or P2 or P2? So the sum should be P1 val plus P1 plus or 0 plus P2 val or 0 plus carrier. If the sum is bigger than 9, you set it carrier 1, some blah blah blah. If the sum or P1 next or P1 itself, or it's P1 next if there's okay, P1. Let's put them a stop at here. But if carrier is still there, it's bigger than what? 0. Relaxed carrier, we should pay attention is that P3 next. New list node carrier. P next. Oh, sorry. The P3 start. That result. Okay, sorry. P result. O L 3. New list 0 1. Okay, we L3 next. So P3 P3 P at P3 equals L3. Carrier P3 next equals this one. Okay, so next one, this one. Okay, L3 next. So it should be okay. Oh, why it takes so long? Ah, shit. Time limit exceeded. Ah, sorry. Ah, shit. Sorry. If wait a moment. Why didn't it stop? Sum equals well P1 or P2. So each of them exists. We just continue until both of them are empty. Oh, sorry. You should be not be here. It's like this. It's P1. If P1 exists, then we set it P1 next. If not, we used P1. Right. Ah, shit. If P1 equals P1 next. Okay, if P2 equals P2 next. Ah, sorry. I made a mistake. Submit again. Shit. Run again. Ah, shit. P3 equals P3 next. Ah, sorry. I should pay attention at the incrementation with more attention. So now it's accepted, but it's not, it doesn't doing very good. It's only the top 50. Really, we can I think one thing we can improve is that when there is no carrier and when there is no carrier and only one linked list is left, we can just append the linked list. So one so add a check here if P1 or if not P1, and carrier equals 0 if there's no carrier and not P1, we just break. Or P2. If one of them is done and the carrier is 0, we can safely break by setting P3 next equals P1 or P2. Yeah, that should be run faster. Oh yay! Look, we now rank top 10 because top 10 of the time, but we don't do good in memory usage. So what's the memory usage? Is that we create new list node every time. Maybe we can reuse them. Yeah, we could just stop changing those things. We say next node is just use P1 or P2. P1 or P2. P3 next. Value equals sum. Now we can improve the memory usage. Sorry. Sorry, there's a syntax error. Cannot say val no. Sorry. Shit, we should do it here. Oh yeah. Okay, so we have improved our memory usage. So this is a good thing to do, I think. Now let's look at the now let's look at the number 3. よし。結構注意しないといけないですね。Number 3, longest substring without repeating characters. Given a string, find the length of the longest substring without repeating characters. ABC, ABCBB, output 3. Because the longest one is ABC. BBBBB, output 1, 1. 3, PWWKEW, 3. Because the answer is WKE. But the answer must be a substring. PUK is a subsequence and not a substring. PUWKE. Okay, this one. Let's first try it with brute force. Okay, so this is very simple. We just look at with 2-time traversal, and every time we can find the longest substring, right? Okay, so let's say let I j for I equals 0, I smaller than s length, I plus plus. For j equals I plus 1, j is also smaller than length, I plus plus. Const total equals s dot length. Okay, now count result. Wait a minute. She said we should get the string. Length. Okay. Wow. How? We should use a map, right? It's okay. Generally, the first thing we got A, and then we check B because B is different than A, so we get 2 A, and then we check B, C. It's totally unique, so it's got 3. But how can I check the third, next one? A, B, C, A. How can I say A is duplicate? We can create a map. Anyway, let's use a map. Map equals. So now we can say si equals 1. So, but if for each round we should reset the map. Oh, this is gonna take a lot of memory. Anyway, we set the map, we set the first digits, and then we if map sj equals 1, we will say we'll break. Okay, this is the count max length. Max count equals 0, 1 if j minus I plus max count equals math max 6 plus 1, so we replace the max count and then we break, but we should set map sj equals 1 and then we return max count. Let's take a look at it again to see if this works. So the first round we traverse all the digits, okay, with I, okay, A, B, C, and then we create a new map and set the map, the existence map, bitmap, I don't know, existence map, okay, we don't know whether the characters are all letters or other may consist of any character. So yeah, we can ignore that. And at the second time loop with the j from start with I+1, we check if the digits exists before. If so, we update the max count and break. Yeah, and then we check, sorry, this is typo. And then we check to the I. So it should be working. I don't know whether, oh, sorry. It's wrong answer. ABC, ABC, BB. So the first one is set 0 and J is 1. J CA and 0, 1, 2, 3. Max count should be shit. Oh, I made a mistake again. ABC, ABC, BB, output 4. If it exists, shit. Because it exists, if it is duplicate, we should not count 2 of them. Oh shit, it's empty string. So it should be 0? Shit. This is my bad. What's this? Output 0 except 1. What? What's this? It should be 1? Description. Oh shit, it should be if I set max amount to 0. Okay. Oh shit. Oh, this is a possibility of empty string and string with 1 digit. So this is shit. Wait a minute. I'll say initialize it with if count mix max account. It should be 1, but if total equals 0, just return 0. This is much simpler. AU, okay, AU. God, I'm not good at algorithms. This is actually the problem of if j equals total minus 1, then max count equals math max. This is different, remember. So this y plus 1 max count. accept it, but wow, it's really slow. We don't use much about memory, but we really slow. Okay, how can we improve? This is one. Okay. Now, to improve this one, let us see. We should see any possibilities of skipping, right? So just to remove those, first comment out those code. Okay, let's make the font size bigger. 16 pixels with 2 spaces, standard. Okay, doesn't change. It doesn't work. Maybe reload it. Oh, this one is good. So at first we check A, and then we check A, B, and then we check A, B, C, and then we check A, B, C, A. So we stop, and then we check B, B, C, B, B, C, A, B, C, A, B. One thing is that we see that when we go to ABC from AB, we check BC. So actually, so the second one BC, BCA, we check it again. Maybe we can skip that. So when we change the flow to, you can see the BC, AB, ABC, we check BC, and then we check BC again. Maybe we can change it to flow like A, and then we check AB, ABC, ABCA. Now now what? So we run into another A. We say this is the largest substring, longest substring, and then when we run to B, we've already know that, oh yeah, so when we already know that B, C are all different because we already go to ABCA. So for B, we can just go from A and again, right? Yeah. So here we just go to, and we just go B, C, A, and we check B, C, A, B, because B again, it's the same. So we go to C, A, B, C. It's again, it's the same. We go to A, B, C, B. Then it's the same. It's the same. So we go to B. we going to don't go to B because BCB is the same. So we just to jump to CBB. Wow, this is faster. So generally, we when we find something duplicated, and then we just update the maximum account, and then start with where the digit exists, and then we jump to the next one. Well, that is cool. So we just follow this one and write the code. Okay. Yeah. This one is faster, right? Okay, so the same one. This should use this one. Yeah. Let's comment this out and let AJ. The total is the same. Constant. Oh, sorry. We just this is the same. Okay, so we should maintain a map, but the map is not only for that. It should not only for the existence, but we should save save the index. Okay, so map here. Okay, so we pick A and we create a map. So each map says A start at index I, and then we go to J. If max J it's not undefined, it's not defined, we say we find a not defined. It means we got A, so we update the maximum account amount, and of course if it's go to the N we update it. So maps J should be J. Okay, but the thing is that here is the problem. If we find a duplicate one, rather than go to next I, we go to the next duplicate first letter, first character of substring. How can we do that? Let's look at the map again. So now we have ABCA. So we get the index, right? So I should be maps map SJ. So it means the map SJ means the first appearance of the number, the character. So I should be +1. Now the other difference is that for ABC, J should be okay. So and if we run that again, but if we set to if we only update I, we can say the I will next round will go to B, the J will be C, so it will be checked again. So we should update J again. J should be we removed one, so J should be next one. j should be j. Oh, j should +1. So it should not be. It should not be. It should not. It should not be broken. It should not break. So we just let it go. J just +1. Okay, j total. Okay, so max j. Okay, so it should work, right? So now we let's look at it again. Look at it again. ABCA. Okay, so we update. We found A, so we update I to next one. So we should up to B, this one, and then J will go to B. So we just check B, C. So this round it should be B, C, A, B for the loop of J. Actually, there's no need to set a loop for I. We just select the map, and there's no need for loop of I. Wow, this is cool, man. For j equals oh, we should oh, we need that. So we don't need for loop, but let I equals 0, map si 0, j equals I. Oh yeah. So now it's a next round is go to I will go to B, and J will go to B again, and wait a minute. If that's the amount, we should remove delete. We should delete the delete map sj. So that. So by this, next time when we go to BCAB, we found a duplicated B, and then we update the max amount, and then maximum count, and then we update I to first B, so we go to C, and then we delete the B. And then by here, we update the B to J here. And then we go to J, go to +1, so we go to C, A, B, C. Once 1 again, we go to A, B, C, B. So here it's different because I equals B, so go to C. First B, so +1, so you go to C, and then B will go to next B, so we'll go to C, B, B. And at the end, so every time we set a loop, we should check the ending, how it ends. So the end is j equals the last one. If it's the same, we already updated. If it's not, we should update again. Okay, should be working. Okay, runtime error, sorry. Let I equals 0. Oh shit. Let j run answer. So the test case is ABBA. At first we said it's A. It's right here. A. And then we said AB, right? And ABB. So we find this B is the same. So we jump to its max. So this should be 2. Okay, so now we updated 2. And then I equals SJB B. So here, so +1. We delete it. So it actually now start with B A. Now it's different. But J is the last, so J minus I. But I is already next one, so +1. So it should be 2. How we return 3? Return max count. Oh shit. Where's wrong? Let's look at it into details. Sorry. Map. The first one is I equals 0. So the map says A. We just modified IJ, okay? I and J. I equals 0. J is 1. Nothing happens. We set map. So for J, we set AB. A1. This one is 1. This one is 0, 1. We set so nothing. So we set map B equals 1. Okay, now we find 0. We find a 0, 2. Now we find a different, the same B. The B is actually 1. So we now set I equals maps A, maps B. Maps B equals 1. So it should be I will be set to 2, and B is set to 3, and the max B, map B will be set J will be set to 3, and the map B will be set to 2. Okay, so this one is 2, 3. It's BA. There's nothing. We will say 2, 4. It's N. So J is the end. J is 3 minus 2. So maximum is 3 minus 2 plus 1, 2. We can expect 2. So, oh shit, I don't know. This seems fine to me, but where did we do run? Run. I want to add a log. Because map SGA. Oh, sorry, I don't know. Without just add log ij. Run some code. Zero 1 0 2, so you're gonna be 2 3. So okay, 0 1, it should be AB. It's okay. So 0 2, so ABB. So there's a problem. So I should be a maximum. So 2. Okay. How to get to 3? This one? But I is already go to set to but I is already set to 1. So I is already set to 2. So next round we should be see. We should see 2 3. Yeah, so it should be BA. BA. Maps A. I know. Sorry. I made a mistake. When we jump to I, we should delete all the keys from the map. Oh shit. So it should be while I is smaller than this one, we should delete them. Delete I. Delete SI. Should be I while I plus. Stop at this one, at here. Oh shit, I made a mistake, sorry. Huh? Sorry. Still something goes wrong. AAB. We get first one. We got 0. Wait. We got 0, 1, and they got the same. So we while I plus I smaller than I smaller than 1 smaller than 0 smaller than 1, we delete 1, delete 0, and then we plus I to plus I 1 plus 1 to I, make it 1. 1 is shit. If I delete it, this will be no longer working. Sorry. Let next I, sorry, const next I equals map sj equals 1, next I. Wow, shit. Wow, it's very hard to get into Google. PWWKEW. It should be WKE, right? Let's take a look at this way. We just console log s substring I j pw p, and then we just go to k. Why? There's no w. Next I should be what? So pw, and then we go to w. So we go to map w plus 1. Next I. Shit. I made another mistake. So this I plus plus smaller than next I will end in next I plus 1. Shit. Minus 1. Shit. 難しいな。これで Google に行けないな。絶対行けないよ。TM, TM, and then we go to M. MZ, MZU, MZUX. There's no T. What? IJ. Wow. There's a long way to go. Should be next I, but oh yeah, it should be next I minus 1. It should be while I is smaller than this one, I plus. I think this should be good. Should this is next I. should delete all the delete maps si current I smaller than +1. So I actually will be. Oh yeah, so we just set it to next I. It's accepted, but so I don't think we need to set this one, right? It's the same actually. Oh yeah, okay. So that performance is not good, we just remove the console, hope it will get better. Yeah, it's we used a lot of memory and cost a lot of time also. Could we be better? So we do the same. We log our substring and look it again to see what happened. So 0, 1, 0, 2, 0, 3 should be 1, 4, should be 2, 5. And 3, 6, 5, 7. This should be this. It should be the fastest, right? But it cost. Actually, this doesn't get improved with our naive solution. Where did we do wrong? Maybe we don't just we need it, right? We need it, right? Yeah, we need it. What do we need? Is it because here? I want to improve this one, but seems the best implementation I can do. Let's look at it again. What's this? This is a PWWKEW thing. Sorry, we were just we test this one, PWW this one, and run the code. Okay, we check PW, PW, and then we PWW, and we go to, oh sorry, that is +1, right? Okay, we PWW, so we got 2 W's, we got WK, WKE, then we got WKW, and then we get a 3. Is there anything we can improve? Maybe we don't need to delay it. Is it because delete is slow? I don't know. Maybe we just don't check undefined. But if it's bigger or bigger than I, then it's okay. And we don't need to do this one. Oh yeah. We just say I equals this one. We don't need to do the while check. We just jump through a lot of code, right? Because when we update the I, what we want is that we don't have the existence table of the characters before I. But actually, we don't need to delete the property, but just check if the index is larger than I. We're sure that we should pick them out. But if it is smaller than I, we just ignore it. We just pretend that it doesn't exist. Wow, this is sound cool. So it should be better. Oh yeah, this is good. But we still have a lot of improvement to go. What is that? We use a lot of memory. Yeah. How can we remove them? Speed. How can we make it better? So the maximum, okay, so scroll if it's bigger than I, we update the maximum amount. And then we set I to next one. J will set to next one. And if it's this, we don't check this if every time. Remove it from the for if, because at the end we can check it once. Just again check it once for all, which means that so J actually stops at J. So we just check it again, right? It's the same as checking this one because it stopped at here. XJ plus 1. Okay, should be right. Huh? What? What's wrong? J is not defined. Sorry. J. Sorry. We use ES6. It should be not. It should -1. It should. Sorry. Should +1 because J is already total. J is already total. Shit. It doesn't change things. God, this is hard. If this is not right, what can we do? I don't know. Map Sij map j +1. This seems the best solution. If it's because max is slow? If j minus I is bigger than max count equals j minus I. It's the same. Man, what should I do? We check. One thing is that when we I don't know, man. I don't know, man. I think we're doing, let's say A B B B B B A. Let's see what happens. Sorry. Shit. Log ij is substring I j +1. We check AA. Oh yeah, I know what happened. We see that for B, we just took A, but actually we don't need to compare them. We just to jump to the next character, which is not A. So A, and we'll find next A, but it's the same. So you can just just jump to A, and then wait a minute. Sorry, it's a little different than that. So if we say we find AA, right? AA, it's the same, and we are sure the AA is this has the same amount, because it's duplicated here. So when we find something, we don't just +1. We will just skip the same consequential SJ. If we jump, so the next one we find B, and we just jump A to that. Oh yeah, we can just start to AB. If this, so if the case is A, C, C, C. So we run AC and A and ACC. We found the same. So actually, according to our B, according to our algorithms, we found AC, AC and SCC. So we go to next CC and next CC, but actually we just go to CB because they are the same. We find this consequence C and B, and we just go to the next one. It should be start with totally different. In case of AC, B, A, B, C, like something like this. Let's say C, A, B, C, the same. But if we do this again, it's only have three all unique character strings. So we just jump to skip all those C and find B and go to C here. Yeah, I find it. Wow. Wow, Sj plus 1 equals Sj J plus equals 1 and I equals J. Is this right? So if this one's if we found C, A, B, and C, it's because they are different. So we are go to see. Oh, okay. So this is the same. This one should be good. Wrong answer. Stop. Wrong answer. What? We. You should again. We didn't. Wait. A. It doesn't change. What? We find A, and then I equals A, and because Sj plus 1 equals Sj, we set I to J, and wow, J plus 1. Sorry. B. So this loop ends is that if plus 1, so J plus 1. Oh shit. J. So wait a minute. So I made a mistake here. Actually, this is wrong. This should be stopped at plus J. So we first plus J and find it if but this will add again, right? Add the J again. So this J is actually right because it will stop at not J. Wait a minute. How can I skip all those same digits? Man, this is I'm really not good at these kind of ending conditions. Let me see. Skip the consequential. So as wow, it's the same. We can jump to that one. So it will be last BB. And then J will be +1. So we don't just so it will be BBB. And okay, so actually this one, I equals J. Yeah. What? It's even slower. What? It's even slower. If I remove the console. It's slower. Why? Maybe we don't. Maybe we don't. Maybe we don't do the high setting, but just at last we will set to right, and we need it. Man, I don't know. Any better solution? If there is consequential, if they're all, if they're, let's see again. See. We run the code and we found that BB, and then we go to BA. So, and then BAA. So actually and then we go to AB and then ABB. Actually, actually according to these output, we could say we should skip. We should stop comparing B, right? Because they are the same. There's no need to compare them. So we should say we set J start the same as I because they are the same. 0. Then I will be set to 1. B will be set, J will be set to, J will be, next one will be A, and I will be B. So it will be B, A. And next time will be B, B, A. Let's run it. B, and then we found BA. B, BA. And then we compare BA. Why we compare BA? Because we found the existence. If we found the existence, we compare B. Wait a minute. First we went 0, 0, and then we jumped 4, 5. Right here, yeah. So it's different. But actually, if they are the same, so if when we comparing BA here, actually wait a minute. There are, we don't need to compare BAAA, which we just, for example, there's C when there's CBA. We need to compare BAA, and then we found again, and we can do AB, and then ABB. So I found the problem is here when we are comparing BA. Actually, we don't need to check next is A or not because they are the same. We don't need to move the cursor, but just go straight to because next one. Here is the problem. So for each loop, so here we should check what we check should be check B, and here we we should just skip. Should just skip at the beginning, right? Because anywhere, if we just say if we start from I here and B, we just compare here, it's this, it doesn't change anything. Even we have A, B, C, D, 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 D. We first check A, B, A, B, C, A, B, C, D, and when we check A, B, C, D, A, B, C, D. We don't need to use the if. We can just, oh yeah. So we're just skipping this D, 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 D. If we found a D, so we test A, B, C, D, and then we check A, B, C, D, D. But actually, when we check A, B, C, D, we can just skip to the next one, D, E, or something. So there's no need to check this if. No need to check this if, right? And they so actually it should be if next one is different. So if say if it's B, then we jump. If there is, we just look. I know what to do. If we will check the next one. If J is smaller than total minus 1, and Sj plus 1 equals Sj. If next character is the same, what do we do? If it's the same, we just continue. No. We will no, we just we don't say if, right? Wait a minute, it's a bit of a mess. If they are not if they are different, and it will say if this one has come before, then we set it, and then we can skip. If they are the same, I will say maximum J minus I. Plus 1. So, I mean, if next character is different from current character, and we can just update it and just continue. but we don't need to check it again. So while we just update it, while j smaller than total and sj plus 1 equals sj j plus plus. Okay, so that means if we found something the same and then we check it, update the account, and then update the j to the right j, and then we do nothing. If the next character is different, and then we will check if it's the same. Existed before. If it is, we will update the I, and of course update the j at the same time. So here may be a problem because when I say while j is smaller than total and sj j if the same, so every round we are keeping while j plus and I equals j. Seems right. Wow, look. We just say B, BA, and AB. We just skipped a lot, right? Wrong answer? Oh shit. Let's copy the input and run the code. So first one is check AB, A, B, YBC, and BCA, BCAB, CABC, ABCB. Oh shit, I made a mistake. Because J is, so the first one is 00A, sure. And then, because J, A, B, C is different, and B doesn't exist, so we'll go to J, we'll go to, J was not updated, J should be +1, 0, 0. Ah, shit. So they're both up to B. Why? Because I is +1. So, oh shit. Start from 1. Doesn't make a difference. Okay, A, B, C. Now we check A, B, C, A. Why we update this? So because we updated when next amount is the same. A, B, A, B, C. A, B, C, A? No, because existed, so A will be moved to B, and B, C, A, B, and C, A, B, C, A, B, C, B. I don't know. I add some console. Sorry, I'm a little dizzy now. Max count. Four. A, B, C, B. Now we got A, B, C, B. So we are going to A, B, C, B, B. Actually, J is going to be bigger. B's A, B, C, B. Because it's the same, so J will be J will be plus 2 total. Because here, I don't know whether it is right. Oh shit, I don't know. But it should improve our code. Max count, max count. B, wait, B, C, B, B. Because J is, while J plus 1 is smaller than total, J plus 1. And I equals J. Minus 1. So here it updates to 4, but actually there's no 4. Why plus 1? Because this is the same. So A, B, C, B. If J is smaller than total. Is smaller than total. And Sj equals this. Next one is the same. So J equals 6. I equals 3. Yi is 3. We should wait. We should check if this exists first. If it exists, we jump to next, and then if let's say A, B, C, A exists, so we update the maximum account and updated I to B. So now we check the B. If next one is A, B, B, we update the count, and then we will just up straight to the next one. Yeah, this should be right? I don't know, man. Shit! I want to sleep. Okay, AB, ABC. ABCA, we updated through 3, right? Duplicate 4. Why 4? Shit. This should be this one. Just seems this is right. Man, I'm really not ABC, 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 AB. I'm really not good at these ending cases. Okay. Wrong answer. B. 2. Why? Okay, the first round we just 1 0 1 0 1 is BB, so it's 2. Actually, it happened, so we update to 1, then it should be this else. I have a feeling that this doesn't solve anything. We have done this before. So BB, why we check BB. I'm really kind of stressed out. Ow, man. I'm going crazy for this one. Okay, we move back to this submission to make it clearer. Right, this is the good one. A bit half. Okay, so if map skip the consequential, it works. A B C. So log ij as substring ij plus 1. Actually place AB, and then we should go to ABB, and then BCC. We'll first check if there's something, check if there is duplicated, and then we skip. So if there is no, we won't skip. But actually we can, right? The only thing is that we don't skip like this. Else while it's plus 1 equals sj, so it's around here, AB. We got AB. If we find next one is B, which is plus, there's no more counting. We just plus to B, then I to B, I to J. I is also here. And then J will be plus 1. So it will be B and B. I don't know if this is wrong, right or wrong. So it's wrong. Let's say A expected 2. So let's say AA got 1. AB. Oh. Oh man, I don't know what to do. So I'm not a really good programmer. I cannot get into Google. Shit. I think this is we want to skip like A B, and then we skip B. It's A B C D, like A B C D D D D D, something like this. Should be A B, A B C, A B C D, and then A B C D D. But actually, if the same, we can just check it again. And then one here. Right? It's even slower, man. Shit, I don't know. Should just use this solution again. Oh wow, this sometimes I didn't do nothing, but it runs faster. So it's mm, so the fastest guy is 84 milliseconds. What's going on? Actually, if we don't skip, doesn't change much, right? Yeah, it doesn't change too much. But I think this is the best I can do. Yeah. Anyway, I'll just look it back sometimes later. Let's see if there is some meaningful guidance discuss. Wow, use C++ we just only 12 milliseconds. How did you do? Let's look at the code. Okay. You mean they're all letters? Max, well, size. If the size and exist, we set it to 1. Else, we set it to 0. And then right L, left. We're into max. What does this mean? I think what? I don't know what is going on. So the first left, this is left. This is right, this is max. Well, left is, well, traverse from left. So if and 0 and doesn't exist, so we set it exists and +1. Then if, wow, this code is difficult to understand. Oh, so it doesn't exist, and I think I've got to know something. Look at our solutions. So there's solution. Wow. Wow, this is a, oh yeah, there's a solution. We can just look at it and understand what is going on. Let's say so actually let's take a look at ABC again. If we go to, if you set a slide window A and then 0, so A and nothing, and nothing, so it should be 1, right? If we said, and then we slide, if because we find the next one, so it's B, and then we find A. So it's 2. So we find C and find B. So C is not C is different from B, and it's not A. So we go to A. We find A. Oh, wait a minute. Why we go to B and A? And A, B, C, and A. So it's 3B. So we first we go to A, B, C, A, and find A exists. So we should be 3. And then we should go to I don't know, man. I don't know. Let's look at the solution. So the brute force, yeah. This 03, it's not good. Yeah. For the sliding window, the native approach is very straightforward, but it's too slow. How can we optimize it? In naive approaches, we repeatedly check a substring to see if it has duplicate characters, but it is unnecessary. If substring Sij from index ij 1 is already checked to have no duplicate characters, we only need to check if Sj is in the substring Sij. To check if a character is already in the substring, we can scan a substring, which leads to ON algorithms. Yeah, but we can do better by using a hash set. Yeah, to check the characters in the current, we can get a 1-1. Yeah, we're doing that just like this. A sliding window is an abstract concept commonly used in array string problems. A window is a range of elements in an array, truly defined by the start and indices, like ij, left closed, right open. A sliding window is a window slides into boundaries at certain directions. For example, we use ij to write by one element, then it becomes I plus 1 plus 1. Back to our problem. We use a hash set to store the characters in current window. Then we slide the index to right. If it is not in the hash set, we slide j further, doing until Sij is already in a hash set. At this point, we found the maximum size of substring without duplicate characters start with index I. If we do this for the all I, we get our answer. Wait a minute. So sliding window slides two boundaries to a certain direction. We use hash to store characters in current window. Yeah, then we slide the index j to the right. If it is not to the hash set, we slide j further. Yeah, doing so until j is already in the hash set. Yeah, we're doing the same. We just hashed a j until it is in the hash set, and then we look at the code of Java. Set if while n jn if set contains doesn't have it, we just set it. Answer, yeah. Else, we use the set remove s and I. Return answer. This is great. Simple. We just rewrite this code with the because with JavaScript. So we slide this window. I'm not getting this right. So we slide this window. We had a set. We add the character. If we have it, we'll remove it. But it doesn't slide to the, just a slide 1 plus 1. The worst case is character will be visited twice by N and J space. Anyway, well, I see. So what it does is just let's say A here, A B C C A B C. So we just start at 0, and then because the first one wait a minute. So the first one start with A because there's no A in this hash. So we add A and then we plus J. So it's gonna be like this. So max is max is 1. And then we check B. There's no B, so A, B, and C. So this is gonna be 2. So A, B, C, A. So there is. So we're gonna remove A. I will plus 1. So it's gonna be B, C, B. B, C, wait, B, C, A. And then it doesn't have A. So we will add them. A, B, C. Now we're gonna B. So yeah, it's gonna be always like 3 in it. Like we're keeping a set of all those unique characters. When we add one, oh this one, oh I got it. I totally understand it now. So we get this set to add all those unique characters. When we add one, when we find someone you didn't have it, we just pushed it, and then we check it again. If we find something in it, we just remove it. And check it again. Because in that case, we would just remove one. Remove if you say A, B, C, D, A. When we find this one, it's the same. So we'll remove like A B C D B. We will remove A, so we're gonna B C D B. It's still there, so we go remove B C D B, and then we add a C D B D. Yeah. Actually, this is not what we do. This is worse than us in our solution. You understand that time complexity. Yeah, so basically every time maximum is everyone is counted twice. Space complexity. Yeah, approaching 3, sliding window optimized. The above solution requires us 2 steps. In fact, it could be optimized to require only 1 end step. Instead of using a set to tell if the character is 12, this is not. We could define a mapping of the characters in the index. Then we can skip the characters. The reason is that Sj have a duplicate in a range ij with index j. How to say this in English? J. What is this? Prime. Oh yeah, prime. With j prime, we don't need to increase I little by little. We can skip all the elements in the range ij. Yeah, that's exactly what I did. Well, actually, we're doing the best. But we're not fast enough. Let's see what happens. Okay, the first one is that they said okay, it map I equals j equals 0. Okay, for it's not for I oh yeah, I don't know. Let I equals 0, j equals 0, j is smaller than total, j plus plus. If map j is bigger, bigger is not bigger. He said it's map is not equals to undefined. Then he said maps if it's already there, I equals anyway. We at last we said j to j plus 1. By j plus 1. We said max max answer is what he's suggesting is that max account max is max account j minus 1 plus 1 is what plus 1. I equals mathmax maps Sij I. Why? Okay, so let's start 1 0 0. If map contains key, so if a map has this character, so the index may be somewhere between I and J. So the I should be, why we use mathmax? Next I mean it should be +1, right? And then J +1, yeah. And then maps J equals J +1. Why +1? It should be J. But this is the same, right? This is same as our code. It's different. Shit. Save. Double. Still we do have these strange cases, special cases. Okay. One answer. I'm crazy for this one. ABBA. Man. Maybe it's just about JavaScript? Oh, shit. Why? Let's try this one. I'm suspicious whether it works or not. Okay, so submit. Bam! It's working. Why? Shit. Shit. Why it's so fast? Huh? This one. Is it working? It's Java. Wow, it's fast. Fuck. I'm not getting this because oh, if S max, because it put what it is put, it's -1. So ij equals 0. Let's write down the code. So let's for a b c b b. So ij 0 0 because they don't have it. So I will be, answer will be 1. Okay. Put the character 1. So a equals 1. So next one is 0, 1, because there's no. So answer is 2. Put A1, B2. A2, 3. A1, B2, C3. 0, 3. Because there is, so I will be get. So it should be so it's put what it put. It's next one. This is the same, right? This is what it puts. It's just the next one. Actually, it's the same as our solution. I'll write it again. Sorry, this is very difficult. Actually 0. Yeah, we don't check this one. Just return max. Okay. It's pending. Shit. Its loading is very cute. Wrong. God, that's right. Max count, so 0, 0. Sorry, man. This is the accept answer, right? So actually, we don't need. I think we don't need this return 0 thing. We just max mount count 0. And we can start from 0. Map 0. This one, we just let I equals 0, j equals 0. If there is, we update the amount. I think we have this is a very more elegant solution. Shit. So max count equals max j minus I. Do we need to plus 1? So the first one is I 0, 0. There's no 0, 0 there. If there is already index in it, it should be we update AI. this one. Max count equals J 0, 0. So it should be plus 1. 0, 0, it should be 1. 0, 1, it should be 2. Then maps J, it should be J. So we'll jump to, if there's, I don't know, just run the code. There's no need to for this one. Seems working, but maybe it's just a wrong answer. Yeah, I know. ABB, my head hurts. ABBA. Console log IJ. S substring IJ plus 1. So it should be, so it is A and AB, ABC, ABCA, BCAB, CABC, ABCB, and then CBB. It's working, but ABBA is not. A, AB, ABB. What is wrong? Because if there is, we should update it by this one. If there is nothing, we should update it by this one. It's actually the same, right? Wrong answer. AB, AA. So AB, ABA. And then BAA. And then BAA. And then AB. And then, so there's always this thing. It should be bigger than I. Huh? ABC, 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 BB, AB, ABC, 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 A, BC, should be, yeah, currently.